So let's continue our step functions. We're going to look at now doing the full problems with using the Laplace transformation. So, example 1, let's just dive right in. We do the same thing we did in the last video. So we're going to rewrite our f of t. Let's do it with both methods, just like I did in the last, just like I did in the last video. Why does it do that? Okay. First method, we do it by jumps, right? By looking at the jumps. So we add t minus 2 squared u of 2 of t. If you have questions with this, go back to my last video. I explained it all. Second method, we add the things up. So it's u of 0. You could think of this as being greater than or equal to 0. Minus 0 u2 plus t minus 2 squared u2, right? You can think of this as being if that helps. So then our f of t would be t minus 2 squared u of 2. Now we need to take the Laplace of f of t, which is equal to f of s, which is equal to so to do this one, you see our c is equal to 2, and they have to match. I have it marked over here which one we're using, right? Look down here at this one I have right here. So it's u c of t times f of t minus c. And the Laplace of that is e to the negative cs f of s. This one could be a little weird because you can think of the t minus 2. Well, you can think of t being equal to t minus c, right? So then you would replace t in for that. Remember, our c is equal to 2. So you can replace t in for that. So then you have t squared u2 of t. We can't forget about this c equal to 2 thing. We're still using this thing here. But now we're looking at a separate Laplace for this one. So basically you should write it like this. We're looking at a separate Laplace for this one. That's what that other f of s means. Right? And then we have our e to the minus 2s. Minus 2s. We plug in c. So now you just look at a separate Laplace for this one now, and that would be, if we go up to here looking at this one, I have it marked. F of s is equal to Laplace of t squared. So our n is 2, so that's 2 factorial, which is 2 over 2s to the s cubed, right? 2 plus 1 times e to the negative 2s. And I think that's the answer. Yep. Yes, it is. So you see how that works. It can be a little weird. So now let's look at number 10. Method 1, right? Going by the jumps, we have 0 u of 0 plus minus 0 u pi plus t minus pi times u of pi. Oh, I'm doing it the other way first. All right, let's go by the jumps. Start with 0, going up by t minus pi times u of pi. And then we're going down t minus pi. So that's u of 2 pi. Right, because we have to go back to 0, so we have to go down that. So, not again. So now if you look at the second method, the one I was doing, 0, u of 0. You don't really have to write out the ones with the zeros. You can kind of skip that. And you end up getting the same exact thing, right? T minus pi times u of pi. You change the sign on the less than. So then minus. Right? Same thing. So that's our f of t. Now we need to find the Laplace of f of t, which in this case, you may notice something. Okay, good, this matches with this, but look at this one over here, doesn't match. So we have to do some rewriting here. We need the 2 pi in there, right? So we're gonna have to rewrite this negative pi. So I'm gonna go ahead and just rewrite this one. So that we can rewrite this to be, if we want, we need a 2 pi and then minus 2 pi. If we add a pi, that'll be negative pi. So now we're going to go ahead and rewrite that again. And I'm going to call this f of s is equal to t minus pi u of pi minus, we can group these together. Then we're going to have a different Laplace transformation for this one, right? So now they match, right? Matches. Excuse me. So let's look at the first one. T minus pi, so our c is equal to pi. Our parent function for this one, or if we plug in t for that, that would just be t. So we're going to have the Laplace of t times e to the minus pi s minus the Laplace of t again, e to the minus 2 pi s, and then we have plus that's just pi times, and we look at this one over here now. Why can't I write? Okay. Now we're looking at this one over here. So that's just e to the negative cs. C being 2 pi. So that's e to the negative 2 pi over s. So that one's done. Now we just have to worry about these other ones, right? Apparently that's the term supposed to be negative. Oh yeah, forgot to distribute that negative in. So that's to be minus, sorry. That's minus. Small mistake. The Laplace of t is just like from the last problem. It was what? N factorial, so it's 1 over s squared. Right? 1 factorial is 1. S over 1 plus 1 is s squared. So that would be e to the negative pi s over s squared minus e to the negative 2 pi s over s squared minus pi e to the negative 2 pi over s. And let me just check this. Yep, that's correct. So this would be our answer. Oops. Okay. That is a pi, by the way. Okay, next question. So it already gives us the form. Isn't that nice? So we can go right ahead. I'm just going to rewrite that. This one's just going to be all of this right here, right? We're just looking at that U of C of t one over here. So if we do that, this one's easy. We're just going to have f of s will be equal to e to the minus, so c in this case is 1, so e to the minus s over s plus 2 e to the minus 3s over s minus 6 e to the negative 4s over s. Is it that easy? There's no way. Let me see. Yeah, that's it. That is it. Okay, let's look at the next one. Number 12. And I think that's it. Yeah, that's it. So number 12, let's see, we have f of t is equal to t minus 3 u of 2t. Okay, so now we go back to the other one, right? So we'll have u of c of t of f of t minus c I don't know why I just wrote that down. We have the parent, we have the t there, right? And then we have u of 2c, sorry, c is equal to, oh wait, our c's don't match here. Don't match, so I'll put that in red. Does not match. Either does this one. So let's look here. So we have to rewrite this. We could what? Make this t minus 2 minus 1 and we can make this t minus 2 t minus 3 minus plus 1, right? So we need that minus, we need the 3 in there, and we need it to be equal to negative 2. So now we can regroup t minus 2, u of 2 minus u of 2. Then we have minus t minus 3, u of 3 minus u of 3. So now we're going to use both of these for this one. So we have t minus 2. So now our c's match, right? So for this one we have e to the minus, it will be the Laplace of t times e to the minus 2s minus, this one would just be e to the minus 2s over s, right? Over here we have minus the Laplace of t. Man, my brackets suck. That's a bracket, by the way. Times e to the minus 3 of s minus e to the minus 3s over s. So now let's go ahead. This is not f of t, this is f of s. Plus of t is 1 over s squared, right? So e to the minus 2s over s squared. I got that from this one up here. Minus e to the minus 2s over s minus e to the minus 3 s over s squared minus e to the minus 3s over s. Okay, let me check this. 11. No, 12. This is 12, right? Yeah. E to the minus 2s over s squared minus e to the, yep. Yep, and yes. Wait. Did I do it wrong on my paper here? Hold on. This is 12. Yeah, we're good. I did it wrong on my paper, apparently. Alright, so this is the correct answer for this one. So that's it for now. I'm gonna have two more parts. I know I was gonna just go to part 3, but I'm gonna go to part 3, and I'm gonna make it. I want to show the proof of how you get from here to here, just in case your professor does ask you a question like that, like to use it, like to solve it using the definition of inverse Laplace instead of using the table. So I'll show you how to do that in the next part with the definition. And then we'll look at some more inverse Laplace. Alright, so see you in the next video.